Hello everyone, and welcome to Software Architecture Monday. My name is Mark Richards, and in this lesson, number 166, we'll conclude this journey of all these architecture styles by looking at space-based architecture. Well, here it is, our roadmap. We have seen all of these architecture styles so far in Software Architecture Monday, and we are now at the end to take a look at something called space-based architecture. I used to make the joke that I did start my career actually as an astronomer. I worked at Braeside Observatory in Flagstaff, Arizona in the US. And so I always made the joke that space-based architecture was my favorite because of the word space-based. Well, it has nothing to do with space, outer space. It has nothing to do with cloud-based deployments as well, although that is a popular deployment strategy. But it's not required. That's not where it gets its name. Space-based architecture gets its name from a computer science term called tuple space, which is defined as multiple parallel processors with shared memory. And you see, that's a great way to describe the shape of this architecture style, because all transactional data is cached in memory. In other words, this architecture style effectively separates the database from all of our processing. So none of those services, called processing units here, ever read or write to the data. And that leverages usually replicated caching to solve that problem. So it's quite a unique architecture style. And as a matter of fact, before the advent of microservices, Neil Ford and I always referred to space-based as a domain-specific architecture style. And I'll explain what I mean in a little bit. But first, let's actually see quickly how this architecture style works. Because we do have things called processing units. And now, for the sake of argument, we'll call these services. But they don't have to be, because early implementations of space-based actually included the entire application functionality in one processing unit. But notice here I've got some customer information services, customer wish list, and these dotted lines represent separate physical storage on these. They're separate physical servers. And we do that for fault tolerance aspect. But we have multiple instances of all of these. And we still have, in fact, a database. But the services don't interact transactionally with that database. But rather, it's done through caching. And that's what that in-memory data grid is all about in space-based architecture. So let's say that I do an update to a customer. Now, notice that update happened right in this service right here. So that service received the request, let's say to update a customer name, something really simple. Okay, or even add a customer. Let's do add a customer. I like that example. Okay. So that request came into that service. Once it adds it to its cache, which is, like I said, usually a replicated cache, tools such as Hazelcast, Coherence, Ignite, Gemfire, Infinispan, all of these kind of tools that are used to implement this data grid and replication engine take over, and what they do is they replicate that data to all same named caches. And so now that customer info service here has that new customer. It's available. Now, because this service was involved in, it received the initial request, let me put it that way, what it does is it then sends that information, fire and forget, to some sort of queue or stream. And then a data writer would pick that up. And that data writer component, whether it be a separate service or an application or maybe a data hub like Ab Initio, would then write that data to the database. And by doing that, that's when we come to the point where we're now all in sync. And so you can see everything is very much eventual consistency. The replication between the processing units is very fast, usually in a tenth to a hundredth of a second. But the database could take a while based on some of the load that we have, because we're processing more than we have connections to that database, and it's the whole idea. Now, there might be times when retrieving archived information because we can't store everything, or when we do a cold start, where we do have to read from the database. And one particular service would do a request to a data reader. It would query all of the customer information, load it into the cache, unlock that cache, and replicate across all other instances. And now we're up and running. And that's how service-based architecture works. But let's see when to use this. Here is its superpower, everybody. This is how to create highly elastic and highly scalable systems. How do you process 1 million concurrent users? Because we don't have 1 million connections to a database. It's space-based architecture utilizing tuple space. How do you go from anywhere from 20 users to 200,000 users within a couple of milliseconds and be able to process all that? That is elasticity. That's space-based architecture. You see, this deployment manager here in the virtualized middleware takes care of spinning up and tearing down processing units, which is why it works really well in cloud-based deployments. But these processing units are not connected to a database. They don't have connections. And so they start up very, very quickly. In other words, their mean time to start is fairly fast. But the other times to use it is also combining that with high-performance systems. We don't have those reads and writes to a database. Reads and writes to data, everyone, is measured now usually in nanoseconds because it's in-memory reads and in-memory writes to data. And that's what the user experience, the user sees. So this is when to use it. It's like I can imagine there's a lot of times not to use it. Oh, and you are correct. Agility is really poor here, as well as cost. It is probably the most technically complex architecture style that does exist. As a matter of fact, there's other times not to use it. If you've got large volumes of transactional data, how do you store 10 terabytes of data in memory? Well, you don't. And so we start to see some of the limitations of space-based architecture. Also, if we are squeezed for constraints of time and budget on the initial start of this system, the initial implementation, I will tell you, you will overrun those budgets and time because it is extremely complex. Also, if we require high data synchronization and data consistency, we will not have it in space-based architecture because of the time it takes to synchronize in memory with that system of record down at the database. So these are times when not to use space-based. Okay, I kind of realized through these that these are supposed to be 10-minute lessons, and I kind of looked back and saw that most of them have been spanning almost 12 minutes. So I apologize for that, but there's so much to talk about with all of these architectures. But this has a sweet spot in a particular domain. High performance, high scalability, and the highest levels of elasticity because we remove the database from the equation. And that's what's known as space-based architecture.